having a lot of solar activity lately, and some people are blaming it on the 3i Atlas, but I don't think it's that, because if you look at this diagram right here, you've got the sun here, the earth here, and this is stereo B satellite. And Atlas is in this area right there. So could be other things exciting the sun. It's an electric universe, but I don't think Atlas is in this case. But what's happened, this third eruption today is going to cross our planet. Now, and as we go through there, I won't stop it yet, but I'll tell you exactly when it happens. And that is at midnight on the 7th. Boom, right there. And what that is universal time. So come back about 5 hours. And if you look, it'll be about 7 p.m. tomorrow night on the east coast of the U.S. That would be, again, you take the midnight in UTC time and come back 5 hours, and that's what you're having. Now, what's interesting about this, it's a brick wall impact. See that? Now, it's not that big of a CME, and it's actually caused by an M7.4, not an X flare. And what's going to happen, you're going to see the solar wind they'll be coming down from some of the kind of outer impacts, but it's going to be dropping to about average, which is about 320 kilometers per second. It'll be under 400 here. Then a brick wall kicking it up to about 500 kilometers per second, increase to over 800 kilometers per second. And you're well over 1 million miles per hour at that point. Now, the big thing about this, because it is a brick wall impact, I'd say tomorrow night around 7 p.m. on the East Coast, you would want to be looking for possible earthquake impacts, simply because of that. Now, other than that, we would be seeing the normal geomagnetic storm results. Dizziness, fatigue, you can have problems with your heart, you can feel like crap when this starts to happen. But that's going to be coming in fast. Now, again, it's just, you've got about 3, there's 1, 2, 3, on the third CME right there, the center of it looks like, and which is the black area, is going to make a pretty good impact with our planet. So again, tomorrow will be the 6th, and then you go into midnight, back that up about 5 hours again. Let's say 7 p.m. on the East Coast impact time. Now, that's going to tell you that the East Coast will not be directly Earth-facing. It will be more like the West Coast and over towards Hawaii through the Aleutians, because of the way that you got an Earth-facing and Sun-facing side interacting with each other. So by 7, you won't be directly in the impact area as far as the East Coast. Still need to keep an eye on it. Now, our update that's coming in from Space Weather, 1830 UTC time, just coming out, guys, is that this is going to cause a G3 geomagnetic storm, which is very powerful. And so that's really going to intensify, guys, that dizziness, the headaches, the fatigue, the joint ache, and again, heart arrhythmias, and stuff like that. And they're saying a strong geomagnetic storm is predicted. The sun hurled another CME toward Earth today. This one looks like it will be a direct hit. The M7.5 class, which is just under an X, explosion from sunspot 4274 has an unambiguous Earth-directed component. In total, 3 CMEs will graze or hit Earth in the days ahead, number 1, 2, and 3. As a result, strong G3 class geomagnetic storms are possible on November 6th, that's tomorrow, through the 8th. After that impact, says solar activity is rising. Suddenly, the sun is very active. Yesterday, Earth-orbiting satellites detected 2 powerful X-solar flares. This interest-compressed movie from NASA Solar Dynamics Observatory, the SDO, shows both, and that's what we're looking at here. Now, these did not have a direct Earth-facing component because they were going out the side. But anytime you see X flares that you can see the X in like this, you're going to have radio blackouts on Earth. No other way around it. Interference with the internet, you may have experienced some of that. But 2 powerful flares. Now, the sunspots will be returning all for the next 10 days or so. And we really have.
Hey everyone, what is up? There is a lot happening. Another video, another live stream, another day. Look at this plasma tornado. This is our 3-hour live feed of the sun. So this is happening right now. That's a 8.6 M-class flare from the sun. Massive coronal mass ejection. Interesting thing to note, which the other channels may not talk about, and we see that right here with our imagery. This is our 193 angstrom imagery. This is an area where the solar corona, the outermost atmosphere of the sun, is deficient, and it is about to go geoeffective. It's not there yet, but it's close. So, I mean, it's kind of hard to distinguish sometimes solar wind features, but generally when it's in this zone right here, we're not yet connected to it. Typically needs to be a little bit more like right there. So we're probably going to have that hit us within the next 24, 36 hours. And these coronal mass ejections that have launched off from the sun, the one earlier today, that one is expected to hit us in about 24 hours from this moment in time, according to the NOAA space weather model, which we have right here. So there are now 4 waves of plasma. This one only shows 3 because we just had that recent plasma tornado coronal mass ejection I showed you. But check this out. We have high velocity coronal mass ejections. Look at the speed on that. This is our scale bar for the velocity, high velocity. And here we see our density. So again, we're going to see 1, 2, and 3 launch. This is from the 1.8X flare, 1.1, and the 7.4 M flare. That one was today. This new one's an 8.6, not in this model. But look at this, how they combine. Hits that co-rotating interaction region, causes a huge increase in the plasma density. That's right there. Look at that massive jump in the plasma density. And that is expected to hit us right around 1 a.m., 2 a.m. Universal Time on the 7th of November. You know, adjust for your local time zone. Also notice how this is coming in with a plasma velocity spike. So often if you get a big plasma density spike, the velocity is actually not that high, one or the other, because just space weather dynamics I'm not going to go into in this video. But sometimes with big solar storm impacts, you get high density and high velocity, meaning you get strong geomagnetic storms, which we are in right now, in fact. And so the fact that we are already having these stronger magnetic fluctuations on the planet, and we're at G2 levels right now, that could strengthen, and then you get a major solar storm shock wave to come in, that is going to be pretty wild. Here